Mark.
Alright, the domain is our x values greater than or equal to 0.
You can be making money from YouTube and because it's YouTube and money.
Remember, it starts at 0, 0. And then here's the key idea. The square root function is really the quadratic function, but turned sideways. So, like, if you remember in the quadratic, our key points on the y's were 0, 1, 4, and they came from 0, 1, 9. So you had 0, 1, 2, 3, and then it was 0, 1, 4, 9. Well, the square root function is like the inverse of the quadratic, if you think about it that way. So our key x points, untransformed, are 0, 1, 4, 9.
Oh, that makes sense.
So the square root of them are 0, 1, 2, 3. So the parent square root function is going to go through 0, 0, 1, 1, 4, 2,
Oh my gosh, I drew my
9, 3.
I did not. Well, I did 10.
So what is,
I put it
well, there's a bottom one for your test.
No, I
This
wrote
is
it
the
down.
top only. The bottom, your test had a bottom.
What's that mean?
The test needed to have a piece down
Oh.
here also.
I did that.
Because you were finding the inverse and we're not finding the inverse, we're finding the square root. All right, so what is the range of this red graph?
The range?
Yep, what are my y values?
Greater
0.
X is greater than or equal to 0.
Range is y's,
Yep.
but
Come on.
y's are greater than or equal to 0.
Oh.
Range is y. Domain is x, range is y. And again, if you didn't want to write it like that, you could also do 0 to infinity, 0 to infinity. It does, in fact, include 0, so your 0 is a bracket. That is the parent square root function. So you've done the domain, the range, and the graph. Let's look at a transformation of it. So now the graph is x minus 3. So a negative 3 inside moves my graph right 3 units. Because remember, it's x minus h, so that means h is 3. So that means that this graph is moved right 3, which means my new quote-unquote vertex starting point is no longer at 0, 0, but now it is at
3, 0.
1, 2, 3.
So all that changes are the x values in that table. So they're just going to transform, like before, 3 units to the right. So it'll be the point 3, 0, 4, 1, 7, 2, so on and so forth. Because my graph did not move up and down, what is my range?
Y is greater than 0.
Did my domain change?
Yes.
Yes. So the domain from a square root comes out taking what's under the square root and setting it greater than or equal to 0. So you can see that the graph shifted right 3 units. The domain then also shifts right 3 units. So instead of being greater than or equal to 0, now my domain is greater than or equal to 3. Or from 3 to infinity. Unnecessary.
I used to be able to do it real good and it sounded like a train.
Are we okay so far? It's pretty, I mean, it's kind of like quadratics, but turned on its side. A little bit different. Yeah.
So, because h is 3, you're saying you add it to the x value to get.
Just like before.
Okay.
So like in the past when we did the quadratics, it was always x plus h, y, a plus k. That same pattern is going to apply to this table. It's still going to be x plus h. And then I'll show you how the y's change as well. Yes?
Can I come in here to guarantee tomorrow?
I'll have tutoring tomorrow.
Can I still come sit in here?
As long as you're not disruptive. My Carotene kids are good.
It's my fault.
Well, he's in the field. He's taking his spot.
No.
Okay.
Okay.
What is my new starting point? The -2 moves my graph what way?
Right.
The +5 does what to my starting point?
Up 5.
Awesome. So instead of 0, 0, it now starts at? How has that changed my domain and range?
It moves right to x is greater than or equal to.
Yep, so the domain is 2 to infinity. And again, when you're solving for the domain, you do not include the +5. It is only what's under the square root. So it's x minus 2 greater than or equal to 0. Now, my range, can I have points below the
No.
starting point of the square root
It would
unless it is?
It would be bracket 5, comma, infinity, and
Can
parentheses.
you write that like y is greater than?
If it was reflected, then your range could be up and down. We'll see a reflection, but not yet. So my starting point's 2, 5. My domain and range are up there. So now those same transformations in the table, it would be 0 plus 2, 1 plus 2, 4 plus 2, 9 plus 2.
Was that ever that?
Now, you can always plug in numbers. So we know that when we plug in 2, we get 5. So same idea as before, it's y plus 5 now. So if the original y values are 0, 1, 2, 3, all we're going to do is add 5 to them to find my new points.
2, 5, 3, 6, 6, 7, 11, 8.
You could also conversely plug in points. Like you could plug in 3. 3 minus 2 is 1. Square root of 1 is 1. 1 plus 5 is 6. So you could plug in points and create a table, or you can do the table idea like we had from quadratics. So you have 2, 5, 3, 6, maybe. Six, 7, and 11, 8. You good?
Oh, I'm great.
Okay. You like this better than other stuff?
Oh, let me finish. Wait. Graph.
What is my starting point on this graph?
-1.
That is plotted -3, 0. The negative in front does what to my graph? Reflects it. So now instead of going up, it's going to go. And the 2 is going to do what to my graph? Okay. So that means that my y values are once again going to change. So you have -3, -1. Normally, if it was just reflected, you would have the point -2, -2. However, now when you plug in -2, you get negative 2 plus 3, which is 1. That 1 gets multiplied by negative 2 and then shifted down 1. So again, that y, x plus h, ya plus k from quadratics still applies. The yak is back. So we already know this one. We already know the y value or the x value here. So the y value would be like negative 2 minus 1. So instead of being at negative 2 for just the shift down 1, it has to be, has to be stretched and shifted down. Well, that's annoying. And then the next point is going to be at 4 minus 3. So 1. And then it's at 2 times negative 2. Negative 4. Minus 1. So. And then let's do one more point. 9 plus 3. Well, it's going to be off my page. Never mind. Plotting this point. You can see how the graph,
I have a different question.
go for it. So, okay, well, let me finish my thought then. You can see how the graph appears to be stretched because of the 2, but because this is the inverse, instead of being stretched, what is actually happening? It's compressed. So it's the opposite again in that sense, because now it's wider. It's happening less quickly. So what's happening is like our points are changing more rapidly on y, but the x's are happening more slowly. Is that what you're going to ask? Oh, okay. What's up?
Okay, so the negative a value like reflects it like downwards.
Yes.
Over the y-axis. Is there a way that we can get it turned the other way?
A negative x.
That's what I was thinking.
Because that negative x is like a reflection across the y-axis, across the y-axis, where right now everything we're doing is across the x-axis. Yep. I didn't do that on your notes yet, do I?
No,
Okay,
I noticed,
we do that.
I noticed there were no negative x's, so I figured that was the case.
It's a reflection backwards, which flips your domain.
Are they going to put like a coefficient on the x too?
Not for this unit. Like we do that maybe in pre-calc. That's like pre-calc stuff. Yeah.
How do you get the -1, -3 point?
I don't have a -1, -3. I have a -2, -3.
Yeah, how do you get that?
So,
-1, -3.
so what happens is that came from my table. So the h value is plus or minus 3. So you have -3 being added to 1. So 1 minus 3 is -2. So that's where the y or the x came from. The y's come from the a and the k. So it's 1 times -2, which is -2. -2 minus 1 is -3. The other option is just to plug numbers in to your square root. The problem with picking numbers to plug in is if you plug in 0, 0 plus 3 is 3. Do you know the square root of 3? I mean, you can approximate it, right? Like, you know the square root of 1 is 1. You know the square root of 4 is 2. Therefore, the square root of 3 has to be between the numbers 1 and 2. And it's going to be closer to 2 than it is to 1. No? Yeah? Everybody's cut. Yeah, that's how square roots work. Like, I promise I'll lie. But like the problem is you can't get that as an exact point to put on your graph. So when you use these in their transformations, you always get perfect square root numbers. That's the only reason I show it to you that way. What is the domain? What's my farthest x point?
-3.
Yeah. So it doesn't matter that your domain now has a negative x value, because even when you plug that in, -3 + 3 is 0, you can take the square root of 0. The range, on the other hand, is now reflected. So instead of being a number to infinity,
Negative infinity to -1.
good. Did I leave them as inequalities on your paper? We're not going to do inequalities. I changed all the inequalities in the homework to equal signs. We're not shading. There's almost virtually no use for it after here. Like, I don't think you'll see it in pre-calc. You definitely don't use it in calc. So I've been adjusting what we're learning at the end of the year now, knowing like what you need to know for next year, and still kind of playing catch up with anything you might have lost. So let's do one more example. Just change the inequality to an equal sign. What is my starting point for this graph? Yep.
4 negative 6.
Perfect. So again, in terms of that table, it's x plus 4, y, what's my a value here?
1.
Yep, plus k. And it's, again, just the opposite of what it was before. So now it's 0, 1, 4, and then 0, 1, 2. So plus 4 is your 4, minus 6 is your negative 6, plus 4, plus 4. So you have 5 and 8, minus 6, negative 4, negative 5. So again, the x's are changing quicker than the y's. So you have 5, 8, and 5, negative 5, and 8, negative 4. So your domain is 4 to infinity. Your range is -6 to infinity. So all I'm looking for on your homework tonight is something similar. Your starting point, 2 points, domain and range.